Hi, in this video we're going to discuss how to evaluate a difference quotient. Now this is a main definition that you need to know before you take a calculus class. In this video I'm not explaining why this is important in calculus and how it's used. I'm just showing you how to evaluate the difference quotient. So the difference quotient is a ratio, and the difference quotient ratio's formula is right here in this box over here. Okay, so you will be given an f of x. I'm going to do two examples for you here. You will be given an f of x. So given an f of x, you will have to evaluate a difference quotient. So you would apply this formula. Okay, let me show you example number 1. So in the numerator, you have to find f of x plus h minus f of x. F of x is already given to us here. I'm doing question number 1 first, like I said. So first you need to figure out what is f of x plus h. Okay, so f of x plus h is when you evaluate x plus h in the place of x. So it's actually f of x is 2x plus 8, right? So instead of x, you plug in x plus h. So you're going to write x plus h there. And then you just distribute and combine like terms. 2 times x is 2x, 2 times h is 2h, and you get plus 8. So that's it. F of x plus h. Just this part. F of x plus h is 2x plus 2h plus 8. So the difference quotient is equal to, instead of f of x plus h, I'm going to plug in what I simplified for that, is 2x plus 2h plus 8. That's what I evaluated for f of x plus h. Minus f of x. Minus, now f of x is 2x plus 8. So when I do minus f of x, I have to do minus 2x plus 8. That means this negative is for both the terms. So whenever we do minus f of x, all we have to do is write f of x with the inverse signs. So since that's a positive 2x, I can write it as a negative 2x, and positive 8 will become negative 8. So we just evaluated our numerator. Okay, we simplified our numerator, in other words. Divided by, we have h now. So let's simplify, let's see what can be done. There's a negative 8 here and a positive 8 which cancels, negative 2x and a positive 2x which cancels. So we are left with 2h in the numerator and an h in the denominator, which the h and h cancels again, and you're just left with the number 2. So that's your answer for question number 1. The difference quotient for the first function is just the number 2. Now let's do question number 2, so you can get a little more practice. So for the first one, our answer was 2. Question number 2. Let's first evaluate f of x plus h to find the difference quotient, because we always need f of x plus h. That's our first part of this expression here. So in the second question now, we're doing question number 2. Instead of x, plug in x plus h. So negative 7 x plus h minus 10. So we get negative 7x minus 7h minus 10. So that's it. Now to find the difference quotient in the formula, instead of f of x plus h, I'm going to write out what I simplified. Minus 7x minus 7h minus 10. Minus of f of x is the next part of our difference quotient. So I'm going to look at my f of x and I'm going to change the sign and I write it because it's a minus f of x. So negative 7x will become positive 7x and negative 10 will become positive 10. The whole divided by h. Let's see what can be cancelled here. Positive 10, negative 10, positive 7x, negative 7x, and we are left with negative 7h over h. H and h will cancel and we'll just get negative 7. So here the difference is negative 7. Now it looks like just by these two examples, I think we can make a quick conclusion or an easy way to figure this out. It looks like when f of x is of the form ax plus b, like a linear equation type of format, always the difference quotient is just the coefficient of x, just the a. See, For question number 1, the difference quotient was just the number 2 over there. Here, the difference quotient was just the coefficient of x, which was negative 7. So we can make a rule. If you have f of x is equal to ax plus b, the difference quotient is just the coefficient of x, which is a. Okay. You will learn more about what it means with respect to differentiation when you learn calculus. Now, the second type of equations are equations of these type: trinomials, quadratics of the type f of x is equal to ax squared plus bx plus c. Let's see what happens when we try to evaluate difference coefficient of these type of functions. So how about we do question number 1 first? Number 1. All right. So in order to evaluate my difference coefficient, I know I need to figure out f of x plus h first. So for question number 1, f of x plus h becomes, instead of x, I'm going to plug in x plus h, and then square goes up on top, plus 5, parenthesis x plus h, minus 3. Now here, it's really helpful and it makes things faster if you know how to do x plus h the whole square using the identity a plus b the whole square. The formula to do a plus b the whole square is a square plus 2ab plus b square. Okay, the longer way to do this would be to actually multiply x plus h times x plus h, distribute the terms out, and combine like terms and get your answer. But instead of doing all that, you can always easily square a binomial using this formula. When you have to square a binomial, you can use the formula a plus b the whole square, which is the first term square plus twice the product of the terms, which is 2ab, plus the last term square. So x plus h the whole square is just x square plus twice the product of the terms, which is xh, and the last term square, which is h square. So that's what I'm going to use over here. So here I get x square plus 2xh plus h square plus 5 times x is 5x, 5 times h is 5h minus 3. So here I have the first part of my difference quotient. My difference quotient is when I take the ratio of f of x plus h. That's this whole thing is f of x plus h, the first part in the numerator over there. So I'm going to write that out. I have x squared plus 2xh plus h squared plus 5x plus 5h minus 3. The second part says minus f of x, so I'm going to do minus of all these terms. Negative x squared, negative 5x, and the negative 3 will become positive 3. The whole divided by h. Let's see what can be cancelled. And positive 3, negative 5x, positive 5x, negative x squared, positive x squared. So we are left with 2xh plus h squared plus 5h the whole divided by h. So in the numerator we have h as a common factor for all the three terms. So I can factor out the h and I can just write 2x plus h plus 5 divided by h. Both h cancels, and my final answer is 2x plus h plus 5. That's my final answer for the first question. Now I'm going to clear this and let's do question number 2, one more example. So to find the difference quotient, again I have to find f of x plus h first. So 7 x plus h the whole square. Remember, x plus h the whole square is x squared plus 2xh plus h squared. So I'm going to write that out here. X squared plus 2xh plus h squared minus 4x plus h minus 1. So that's my f of x plus h. So now I'm going to try to find my difference quotient. So in the numerator, I have to find f of x plus h, which is, now I'm going to write this out by distributing the 7 into each of these terms here. Okay, like that. So 7x squared plus 14xh plus 7h squared minus 4x minus 4h minus 1. And the last part is minus of f of x. So this f of x, I'm going to write it with the negative signs. Pick another color for now. Minus 7x squared plus 4x plus 1. So I change the signs of these and wrote over there. Divided by h. Let's see what can be cancelled now. I know that there's a positive 1, negative 1 that can be cancelled. Positive 4x, negative 4x, negative 7x squared, positive 7x squared. So I am left with 14xh plus 7h squared minus 4h divided by h. Obviously, in the numerator, we have a GCF, or greatest common factor of h. Taking it out, we get 14x plus 7h minus 4 divided by h, and they cancel, and our answer becomes 14x plus 7h minus 4. That's our difference quotient. Now, in the first question here, our answer was 2x plus h plus 5. That was our answer for the first question, right? So remember how in the last section over here, when we had f of x of the type ax plus b, we could have easily figured out the difference quotient to be a. Similarly here, if the difference quotient is of the type ax squared plus bx plus c, let's see if there is a pattern. So in order to figure that out, I want you to check out some answers here. So here are some questions and here are some difference quotients. These are the functions, and on this side I gave you their corresponding difference quotients. Just to see if there is a pattern here with the answers. Okay, so question number 1 and question number 4 has compare it with ax squared. Generally we can call this ax squared plus bx plus c, right? In question number 1 and 4 we have a is 1, the coefficient of x squared is 1. So they both seem to have the first two terms the same as their difference coefficient, and then they're just using the coefficient of the linear term, negative 8 over there, and look here, this question, negative 2 is the last part. So this 2x plus h seems to be in both answers, and the coefficient a, if you multiply with 1, is just the same thing. Let me show you why I did that multiplying with 1 part. So the answer, the difference coefficient looks like it's a times 2x plus h and plus or plus b or minus b or whatever is b, positive or negative. Whatever is b, you just put that at the end. Let's see if that works. For the first one, a is 1, so 1 times 2x plus h, and the coefficient of x or b here is negative 8. You just put negative 8 as your answer. Let's see if it works for the second one. So here a is negative 5. So as per the formula, it should be negative 5 2x plus h, and b here is positive 4, so you should just put positive 4 at the end. Let's see if that was correct. Negative 5 times 2 is negative 10x. Negative 5 times h is negative 5h plus 4. It actually worked. Let's see for the next one. Here a is 4. So 4 times 2x plus h plus or minus b, whatever that's there. 4 times 2 is 8x. 4 times h is 4.